Hello, good morning. This is the part B of the lecture number 2. Okay, lecture 2, part B. Now I have reached with you last time to the number page 6, slide 6. Okay, now um, I want you also to get the PowerPoint from Blackboard so that you follow me when I talk about them. So we go now to number 6. Here is number 6, and it is reactor plant protection and safety, primary systems, objectives. Describe the purpose and basic operation, major components, and design features associated with the following reactor plant system. Nuclear instrumentation. Okay, the reactor has many nuclear instrumentations uh, like measurement of temperature, pressure, neutron flux. This is very important. These things could be measured with devices like thermocouples, which you are familiar with now. We have taken experiments on them last semester. And pressure gauges, simple, that is not that difficult. And neutron flux determination. We use devices for this called SPND, self-powered neutron detectors. These are just like the thermocouple, but a little bit thicker because it has some materials in it. So the SPND is a device that measures the neutron flux, and all these are inserted from the bottom of the pressure vessel. Okay, now rod control. The rod control, we have a device called it is responsible for lowering and inserting the control rod in the core, and it is especially for the because there are two types of control rods: regulating rods and emergency rods. The emergency rods, actually, they drop by themselves due to gravity. We want to emergency shutdown, they drop by gravity. Okay, and the regulating rods are controlled by certain devices. Okay, reactor protection. When we talk about reactor protection, we are concerned about the safety of the public. Remember, we are concerned about the safety of the people of the US in general, and in particular the cities close to the reactor site. So, what are the measures to protect the people? We have 3 layers of protection. First one is the cladding. You see, because all our concern is we don't want the fission products to spread to the public, spread out in the atmosphere. So the first barrier is the cladding. The fission, when the fission happens, and the uranium are cladded inside a zircaloy for cladding, and this metal prevent the fission products from escaping to the outside. The second barrier, supposedly now there is escape of fission product for failure of the cladding or some sort. The fission product will go to the primary cooling circuit, and this circuit is a closed circuit. It is a closed circuit, so this is the second barrier. This is the second barrier, and this closed circuit is all within the containment building. Because what happened in this closed circuit, water take the heat from the fuel, goes to the steam generator, and back through the pump to the reactor. So all that happens in the containment building. So when the escape of fission products happen in this liquid, it will be within that piping and component boundaries. The third barrier, supposedly now your piping is broken and the fission products are escaped now because they were in the liquid, in the water. They escape. When they escape, the barrier here now is the containment building. You see, the containment building is closed, and there are even water spray right away will work, because when the water goes to the containment building, it will flash into steam because it is at high pressure, and the atmosphere in the containment building is atmospheric pressure. So right away the water will become vapor. You see, so there are spray work immediately. In addition, of course, we have emergency core cooling. In a situation like this, we have emergency core cooling. We will talk about it. Oh, here it is, emergency core cooling. This is a system with pumps and water tank outside, bring water to cool the core right away. To cool the core, called emergency core cooling. Okay, so these are the measures we take for the reactor protection. So when we the third one, fifth one is the residual heat removal, shutdown cooling. Listen, please. When the reactor is shut down, we are going to operate a system called residual heat removal. That means when the reactor is shut down, with the help of this system, we keep running the cooling system. Why? Because when the reactor is shut down, there is still heat in the fuel, because the fuel is radioactive, and when it is radioactive, it will emit heat also. It is highly radioactive, so there is heat, and there is a system to take away this heat, which we call it residual heat removal. This system works during shutdown all the time, okay, until the next startup happens. Then the residual heat removal system job finishes and the actual cooling works. So these are the systems which we are going to talk about. So now we go to the next slide. It's the next slide, number 7. Here it is, reactor vessel and internals. This diagram shows you the reactor vessel, which is a cylindrical vessel, and it has the control rods from top, and that control rod drive mechanism, this is the system for the responsibility of lowering and inserting the control rods, the regulating control rods, that control rod drive mechanism. Okay, so that is on top of the reactor. Then comes the head of the reactor, closure head assembly, and then comes the inlet nozzle, he called it, which is, we call it cold leg, and outlet nozzle, we call it hot leg. Please, if you have a pencil, put a mark on this, or between bracket, for the inlet, write cold leg. For the outlet, write hot leg. Okay. Then comes the core baffle, and then there is a neutron shield panel. See that blue? The neutron shield panel is a metallic structure that try to shield the pressure vessel from the fast neutrons. You see, because if you remember the last semester when we talked materials, nuclear materials, we agreed that the fast neutrons are the ones responsible for the radiation damage of the material. So these pieces of metal we put as a neutron shield will try to help the pressure vessel of the steel of the pressure vessel from radiation damage. What else in this diagram? The bottom support plate and lower instrumentation guide tube. Look, I told you the instrumentation all comes from the bottom of the reactor, and you will see the baffle and the fuel assemblies. Now, so this is a good picture for the reactor vessel and internals. Okay, we go to the next slide now, and the next slide is this one. Reactor plant protection and safety. Now, what is the, first of all, reactor coolant system. Reactor coolant system, the purpose of the reactor coolant system is it's a medium to transfer heat generated in the core to the steam generators. That's the main purpose of the reactor coolant system. And by the way, write with your pencil on this reactor coolant system also RCS, because here in the nuclear industry we use a lot of these acronyms, please. So RCS is the reactor coolant system. Okay, now what is the purpose of it? We just said transfer the heat. Then it is acting as a neutron moderator and reflector. Okay, what is a neutron moderator and reflector? During fission, neutrons are born. When the neutrons are born, they are born fast. And to do another fission, you have to make these neutrons slow in energy. We call it thermal or low energy neutrons. What material makes the neutrons slow energy is the moderator. What part of the moderator is the hydrogen in the water? You see, the hydrogen in the water acts as a moderator. So when that fast neutron interact with the hydrogen, it will slow down. It will lose energy by scattering. You see, so the water act as a heat removal system and a moderator and a reflector. You may say, what's a reflector now? Now, this is the core, and this is the fuel inside the core and everything, and we have water. The neutrons try to escape. So the presence of water return it back. That's we call it a reflector. Reflector, to reflect the neutrons back to the core. So the water is acting as a moderator, reflector, and heat removing system. Okay, that is not on this is not all the job of the water. There is another job. It acts as a solvent for soluble poison. Okay, now we add to the water boric acid. Why? Because at the beginning, when we first load the reactor, it has a lot of reactivity because the fuel is fresh. It has a lot of reactivity, so we don't want to use control rods up and down, up and down. We add boric acid to the coolant in certain concentration, and that boric acid will have, which has boron in it, and the boron will absorb the neutrons. That will make the balance possible for the operation of the reactor. So the medium for the for this boric acid is the water, and the water is the primary cooling system of the reactor cooling system. Okay. Now, but the RCS act as a barrier, reactor cooling system as a barrier against the release of radioactive material inside the containment. I told you the three barriers. First of all, the cladding. Second is the reactor cooling system. Third is the containment building. So as you see, one of the jobs of the reactor coolant system is acts as a barrier against the release of radioactive materials. Okay, so we go to the next slide now. The next slide here is this one. Reactor coolant system major components. What are the major components of the reactor water system and reactor coolant system? First of all, the reactor vessel. I just showed you the diagram for the reactor vessel. Hot leg and cold leg piping. Okay, I also showed you that and I told you to correct. Okay. Steam generators. So this is the device where we get the steam. We need the steam to run the turbines. So the steam generator also in the containment building. So when the hot water comes from the reactor through the hot leg, it goes to the steam generator, whereby the water that comes from the secondary circuit is going to get evaporated and becomes steam. Now that hot water which we give to the steam generator, it will give heat to the secondary water steam to make it steam, secondary water to make it steam, and it goes back to the reactor, just lowering in temperature. It doesn't become steam, remember, because in the PWR it is water running in and out, just water. There is no steam generated in the reactor. Okay, so the steam generator job is to provide steam for the secondary cooling circuit. We have another device called pressurizer. How do we control the pressure in the PWR? We control the pressure with the help of this device, the pressurizer. Okay, now how does that happen? I think we will see the pressurizer in detail, but let me explain to you. If we want to increase the pressure, this pressurizer has two parts. In the lower part, there's a heater. In the upper part, there is a nozzle. There are nozzles that spray water, cold water. And the pressurizer normally has two regions, liquid region and vapor region. So if I want to increase the pressure of the whole system, and this pressurizer is connected to the system, of course. So if I want to increase the pressure, what do? I give a signal to the heaters to operate. And the heaters will get heated, and the heat will be generated, and that will increase the temperature of the coolant. And the pressure also get increased because we don't allow the pressure to go to the saturation. Okay, so the pressurizer, if I want to increase the pressure, I run the heaters. Now if I want to decrease the pressure, what do? I run the spray of cold water in that pressurizer, and that will condense the steam, and the pressure will get reduced. Okay, so that's the job of the pressurizer, to control the pressure of the PWR. Okay, pressure, temperature, flow instrumentation. We just talked to you about it in the last paragraph. So we go to the next slide. Here is the next slide. The next slide, reactor